Hey guys, welcome to your 4.7 notes. These are our last notes for chapter 4. We're talking about sequences and functions. By the end of the day, you will be able to not only identify, but to also extend patterns and sequences and to represent arithmetic sequences using function notation. Oh, guys, just get so excited. I'm so excited. Okay. So let's start out with a definition, talking about a sequence. Not only is sequence my niece's favorite game, where you stick like cards together and try to find a pattern. She loves, is it Disney sequence? I think it's Disney. She got like Disney characters and try to get them all in a row. You know what? I lied. They're animals. It's definitely animal sequence for kids. Anyway, so she finds all these animals right next to each other, try to get 4 in a row. Just like a sequence in the sequence game, you get them all next to each other. A sequence is an ordered list of numbers. So it's numbers together in a list. The key idea here is that they form a pattern. Just like you want to get 4 in a row when you're playing junior sequence junior, whatever. Each number in the list is called the term. It's a term of the sequence, but we'll just refer to it as each term. So when you hear term, think of like, this is a term, this is a term, this is a term of a sequence, like that. Okay, cool. So we're going to describe a pattern. What are the next 2 terms of each sequence? Well, when we look at our first one, example A, I noticed that the change here, we have a difference each time we add 3, add 3, add 3. So once we figure out what that pattern is, we can figure out what comes next. So to add 3, 14 plus 3 is in fact 17. Excuse me. Also notice that terms are separated by commas. That's very important. Separate your terms with commas. And then we add 1 more plus 3, giving us a 20. Yay. Okay, cool. And then the next sequence, to get from 2.5 to 5, we could add 2.5. However, if we do 5 plus 2.5, that is not 10. So try again. Another way to get from 5 to 10, I know, is we just multiply times 2. That's great. If we continue that pattern, that works. And we can take it backwards. That also works. Yay. Okay. So let's do that 2 more times to get 2 terms. 20 times 2 is 40, and 40 times 2 is 80. So that was super. So your most important key idea of the day is this right here. That once you know the pattern in a sequence, you can extend the sequence. That is, you can add on to it. You can find some more terms. Sometimes you can model a sequence with a function rule. So that's fun. That you can use to find any term of the sequence. So you don't need to like write out the whole list. If I asked you, hey, what's the 5th number? What's the 5th term in this sequence? You could count 1, 2, 3, 4, 5, 17. 17 is the 5th term. That was easy. But what if I asked you for the 1,000th term? You could write out 1,000 terms. And if you want to use your time like that, that's great. However, there's a faster way. I'll show you later. Okay. Yay. Let's talk about a very special kind of sequence. We have an arithmetic sequence. So it looks like arithmetic, which is like adding, subtracting and stuff. An arithmetic sequence is one that has It's one like this. It's one where the difference between consecutive terms is constant. That means the difference between terms doesn't change. We call it a common difference. For example, if we're looking for a common difference here, well, here we add 4. Here we add, oh, shooties, magooties. So there's definitely a pattern, but it's not an arithmetic sequence. So nope, it's not arithmetic because the difference between the 2 terms not constant. It's not the same. Shooties McGooties. Let's try again. Here, what is the difference? Here we add 5. Here we add 5. Here we add 5. Yay, we did it. Okay, so is this arithmetic? Yes, this is arithmetic because it has a common difference. Yes, the common difference is 5. So think about that. Get it? Okay, anyway. So a sequence is like a function. That is, you can use functions to find any term of your sequence. So a sequence is really a kind of function where your term number is your input value. And then the value of that term, whatever the term is your output. Oh, I just said it. Oh, man. The input is the term number, and the output is the term itself. For example, if this is our sequence, we have our first term, which is 7. Our second term is 11. Our third term, here, we'll do this deal. We'll write them with ordinal numbers. That's what these are called because they express order. First, second, third is 15. The fourth term is 19. So in this case, our term number is our input, and the term itself, the term value, that's our output. That's going to be what the sequence is. 7, 11, 15, 19. Super duper. But what if I want to find the 50th term of the sequence and I don't want to write them all out? Well, I'm going to show you a shortcut. No, I'm not. You're going to figure out the shortcut. Oh, let's figure out the shortcut. Okay, so here's my hint. You can use the common difference to figure out the pattern, but instead of pattern, let's call it a function rule. Function rule, as in like, man, that rules, not roll as in. Okay, let's roll over this. Okay. For this sequence, we need to find the common difference. So the difference here is a positive 4. We are adding 4 each time. So our common difference is 4. That's very important. Keep that in mind. Do not forget it. Okay. So let's say that n is the term number of the sequence. This guy is up here. Okay. Then we're going to say that a of n, nope, sorry, wrong color. A of n is the nth term of the sequence. Check out that function notation right there. Amazing. Okay. So a of 1 is 7. Cool. But then to get term 2, we took a1 and then we added our common difference to it. We got 11, right? And then to get a 3, we added our common difference, but we added it twice. To get our 4th term, we added our common difference, but we added it 3 times. So, in order to find a of n, we start out with our first term, and then we add our common difference. However, well, we just add 4 plus 4 plus 4 plus 4 plus 4. But how many times do we add 4? Excuse me. Well, when we had 2, we added 1. When we had 3, we had it twice. When we had 4, we added it 3 times. So to add n, we add it whatever n is, but take 1 away. So it's n minus 1. So what's the 10th term of the sequence? Well, let's just let 10 be n. Not because they rhyme, but we're going to plug 10 in for n. Okay, let's follow that same rule. So it's going to be 7 plus adding 4, not 10 times, but 9 times. I could write 1, 2, 3, 4, 5, but to save you on time, what if I just said, hey, there's 9 of them. Haha. Why 9? Because we need to take our 10 minus 1 So that's 7 plus 4 times 9, which is 7 plus 36, which is 41. Nope, 3. I lied. 43. There you go. So if we kept adding on to our sequence, the 10th term would be 43. And you guys, that's the pattern. If we wanted to find the nth term, we already said way up here, hey, let a of n equal the value of the nth term. Okay, so our nth term is a of n. We plug in n. If we want to find like the 80th term, we say, well, a of 80. Okay, cool. Our first term was 7. That's what we started with. The term number, well, that's n. Excellent. And then the common difference in this case was 4. So what pattern did we find? How did we plug these, how did these values fit into here? Well, we wanted to find our a of n. So, we said that's equal to whatever our first term is, and then we added our common difference. Oh, sorry, our common difference, which was 4, and minus 1 times. Okay, so if we have a term number n, we take our first term and our common difference multiplied by n minus 1. That's what we did. That was our pattern way up here. Oh, yay! Guys, guess what? That pattern works for literally everything. So you can find the term of an arithmetic sequence, and you only need to know 2 things. First, you need to know the first term. And what we do to write that, we say, hey, you know what? That's going to be A. If we have a sequence A, we're going to call it A because we like it. But A sub 1, we say sub 1 because it's a little 1 below it, like a little footnote. It's like exponent, but not. There's a term for it. Oh, subscript. That's what it's called. A sub 1. We're just going to call it that. And then the common difference, how about D as in difference? So common difference, D. Replace that. Color, code, magic. Okay, excellent. So A sub 1 plus n minus 1 times D, that's the rule to get the nth term of a sequence. So you can find any term or the nth term by saying a of n is what we call it. There we go, that's the rule. Love it, memorize it. Seriously, you'll need it. Okay, cool. Let's do an example and then call it a day. Yeah, here we go. I'm gonna copy this real fast. All right. A subway pass has a starting value of $100. After one ride, the value of the pass is $98.25. I'm just gonna highlight as we go here. One ride, the value is $98.25. After 2 rides, its value is $96.50. After 3 rides, its value is $94.75. Write a rule to represent the remaining value on the card as an arithmetic sequence. What is the value of the pass after 15 rides? Okay. Well, what's the common difference? Notice that when we start out with 100, when we have our first term, we haven't subtracted anything yet. So we have subtracted 0 things. What is our first term of the sequence? It's 100. We start out with 100. Starting value is $100. Okay? And then we do 1 ride. So our second term, well, here, let's write it right here. So we have 100 and then 98.25 and then 96.50 and and then 94.75, etc. There, that's going to help. Okay, so when n equals 1, that's our first term. It's our starting term. Boom, that's done. Okay, after one ride, that's our second number. The value of the pass is 98.25 because we have subtracted $1.75. Hey, that was our common difference. I don't know if I ever pointed that out, but it's $1.75 each time. Minus 175, minus 175, minus 175, etc. Okay, so we subtract once, we get 98.25. We subtract another time, we get 96.50. So for the nth term, we need to subtract it n minus 1 times. And that's where this n minus 1 comes from. It's because we're subtracting 1.75 that many times. That's a fun connection. So what's the nth term? Well, let's plug it in. Okay, what is our first term of the sequence? Our first term is 100. See you later, you are now 100. Okay, n we need to keep because what is the nth term? I don't know. Let's plug in n for n. Okay, sounds good to me. Minus 1, cool. What is our common difference? Negative 1.75. It's very important you write that as a negative 1.75 because we're going down. We're losing money. Or we're going to leave it like that. Ta-da! Super duper. Oops. Beep. Okay, excellent. So, after taking 15 rides, that means we need to find, not the 15th term, we need to find the 16th term because the first term is 0 rides. The second term is after taking 1 ride. The third term is after taking 2 rides. So if we want to find 15 rides, we need to find the 16th term. Okay, well, let's plug it in, shall we? So this says that a, not of n, but of 16, a of 16 is 100 plus 60 minus 1 times negative 1.75. Well, I'm no expert, but I know that 16 minus 1 is 15, and 15 times negative 1.75 is negative 26.25. So that's how much money we've spent on our train ticket, subway, ride, metro extravaganza. Subway. Okay, and 100 plus negative 26.25 comes out to $73.75. We're working in dollars. Voila. That's how much money you have on your subway pass card. Subway pass. You did it. Key idea of the day. To find the nth term of a sequence, start with your first term and add your common difference n minus 1 times. That's it. Sequences are awesome. And I hope you have a fantastic time on your homework.